Thank you so much. Greg, thank you for that. Well, it's an honor to be here with SoCalBio, and I'm glad to be here because, well, my company makes little robot pills that swim around inside the human body. This is what we call PillBot. And PillBot is one of two things. PillBot is either basically a cheap little piece of drone hardware that doesn't really mean much, or PillBot is a first step into a new world. We would like to call it micro-robotics in the human body. And the only way we're gonna be the latter of those is if we are able to learn from the people in this room. Because if we're good at making hardware that can swim inside the body, what are we gonna do with it? And how are we gonna control it? Are we gonna have humans always in the loop, or are we gonna maybe let machines help us? And so that's kind of why we're here today. And thank you so much.
Can we play the video before we go to Kishal?
The inspiration actually began earlier in life. We went to see this movie called Inner Space. You just sort of assume when you're young and you see stuff like that it's real in some way, or that it will be real in some way. The question we ask is, could we maybe turn a couple of them to the hospital into a Zoom call? Our dream of creating a PillBot is kind of beginning to become more and more real. What you see right here is kind of where we are right now. And what is it going to look like in the future? Like, do we make it smaller? Maybe it could be like the 2001 Space Pod, the little robot arms that come out. PillBot is now micro-sized. It's in your brain, and we might be able to catch things like cancers like tens of years before you might otherwise catch them. So here's the future of telemedicine.
Do you know the U.S.?
Thank you, Annette. He started as such a cute little kid, right? And look what we got now. Kishal, please. But I know.
Hi everyone, can you guys hear me?
Yes.
Great. So
We are using Xbox controllers and directly driving these robots around. And so we're bouncing off the walls of the stomach, not really causing harm, but we see AI in its first iteration as a way to just do driver assist. Hold this thing in place, create a stable platform. It doesn't need to be a chaotic little radio controlled robot. It can actually be a place upon which we can look around and diagnose things. But in future iterations, it should start to become like a heads-up display for a doctor. It should see what might be a lesion and alert the doctor that there's a certain likelihood that something has been detected, and to draw attention to it. And I think as time ultimately goes on, maybe it's a chance for the doctor to sit down. This could be a mass screening tool where most of the time the robots could go do their job, and only when necessary you bring in the true experts. And so we see it as a spectrum, and I think we're just trying to figure out how do we take these first steps. I think Gaushal can help us to understand that, because you're well ahead of us.
So let me address the theoretical aspect of it. Artificial intelligence is an all-encompassing term.
Opportunity for a mixture of machine intelligence and human heart. If I get myopic and I just think of the endoscopy population that we're trying to affect with our robot pills, we see a standard of care where if a doctor wants to look around inside your body, you have to be knocked out, totally unconscious in many cases, while we jam a tube into your body and look around. And then, you're gonna come out of that, and eventually someone's gonna tell you what happened. But if we can leverage AI appropriately, because there's no way these robots are gonna work without some amount of this, right? If we can do this appropriately, you could be in your living room having a Zoom call with your doctor, fully lucid, in the comfort and safety of your own home, while your doctor has a look around inside your body, and they can then use that bedside manner. And so I think my hope is that you get a mixture of these two that might represent the best of both worlds if we try really hard.
Yeah, I'd say, there's a fantastic TED Talk from about 10 years ago that Malcolm Gladwell did, talking about the Norden bomb site, which was this piece of tech that was developed right before World War II by a Swiss engineer that basically, through a very rudimentary computer, let a aircraft, drop a bomb theoretically, and his whole thing was he could put a bomb in a pickle jar from 10,000 feet. And yes, in clear skies at low altitude, flying really slowly, you could put a bomb in a pickle jar at 10,000 feet. And what became very apparent during the Second World War is you can't fly at low altitude very slowly on clear days to drop bombs. But what's interesting with the story is that now the U.S. and other countries can put a bomb in a pickle jar from 60,000 feet using things like AI and ML. And I think in the whole thesis of Glado's talk, and please watch it because he does a much better job than I do, but his whole thesis is how little that actually matters. What matters is where's the pickle jar in the first place, and why are we dropping that bomb? I think what's the problem, what the potential drawback with ML and AI is that it still matters what the question is we have to ask, and the limitations of the questions we think of asking are the limitations of the response that the models can give us. And until we sort of reconfigure the system around teaching people how to ask those right questions in all different ways and focus less on the things we can build with it, that's forever going to be what holds us back until we solve that paradigm.
So do we?
When I see these movies as a kid, I want to become an aerospace engineer because of what I see hyped. Recently in Boston at AdvaMed, we got a chance to hang out with other medical device founders and FDA reps, and you realize everyone, including FDA, want to see these tools brought to bear. The thing that I'm excited about is that I think that when COVID happened, something beautiful happened in our society where you had FDA regulators up at midnight working with people from pharma and from industry and from science, somehow just doing anything they could to make things happen. And so I think that we're at this moment where tech has advanced a bit, and I think that the general public is expecting advances like this. I think we just have to ask ourselves, how do we do it right? That if we keep asking those questions and we collaborate, I think we can definitely make some very cool things happen.
Yeah, and I would say that we are
Hardware side, so did you find it different here? You got hardware, a little bit of software, but most focus on the hardware, so what do you see on that?
What I've appreciated is that in 17 years of designing med devices as an aerospace engineer who really appreciates a Norden bombsight reference. In fact, I kind of like to think that Pillbot represents the cool factor that drew a lot of us to aerospace, but tuned towards healing, which is a lot of fun. That's heartwarming. But in my experience bringing medical devices to market, we've done atherectomy catheters to cut plaque out of arteries, vascular closure devices to get you home sooner, endometrial ablation to help you avoid a hysterectomy, therapeutic hypothermia to maybe reduce the impact of stroke or trauma to nervous tissue. And in all of those journeys, and finally including robot pills, FDA has only ever asked to bring three things into alignment, which is this thing that you want to do. Is it actually safe? Are you going to hurt people doing this? Does it actually work? And then finally, are those two things tied to an actual indication for use that a doctor is asking for? If you can make something that is safe and it works and doctors are using it to help patients, FDA are your best friends, and they're here to help. And so I think if you approach it with that kind of open heart and open mind, and you're willing to treat them like collaborators, that's probably the best way to begin the conversation.
Great, thank you.
Is for me, just looking at the history of Endiatx, I've been heavily involved in this. We incorporated about 4 years ago. Maybe 5 years ago, I got really serious. But then there were 4 or 5 years before that where I would just draw the logo and the margins of my notebooks at previous med device jobs. And so I spent as much time dreaming about founding this company as I have working with my friends and actually creating it. And so my hope is that if anyone has a crazy idea that keeps you up at night, understand that you don't have to be ready, you don't have to be fully qualified, you don't have to be funded. In fact, perhaps the most effective founders are the ones that don't have anything to lose. Because if you can go in full bore and go all in on your idea, you kind of get a chance to create a little bit of a social maelstrom, so to speak. People see this passionate founder that won't quit. That has more value than you might think it could have. So my advice would be reach out to other founders, look at local accelerators that can help you. Obviously USC has incredible entrepreneurial support, and then there are other accelerators that are also great. But the bottom line is, if you have an idea, start it right now, because by the time you finally feel ready and safe to launch your company, you're probably about 10 years too late.
Appreciate that, thank you. And
A little bit about the question of when is your tech or your offering ready to release to the general world? And correct me if I'm wrong, but I think that this is one of the fundamental questions. And this is where the entrepreneurial community, the venture community, doctors, even patients, can understand the beauty of an MVP, a minimum viable product. I like to tell people that if they invest in us, they're investing in our dream of microscopic brain surgery robots, but please consider the reality of a little eyeball that swims around in the stomach. And our hope is that people will be willing to grant us this dream and then work with us with what we have right now, which is quite humble. And if we're honest about that, and if this first offering has some tangible value, which I think everyone here has something that certainly has value, then you have a really harmonious situation. So you don't have to feel like you have to bear the weight of the world on your shoulders. Push it forward one notch and see if you can get people on your side.
Yeah, I think
Like about patents is that you put a provisional in, you have 12 months to fill it out. And the neat thing is, in the last 12 months, we've had some amazing people join our team. And I'm really proud to be able to say people that are coming on board be like, I get to put your name on this patent, welcome to the company. It's exciting. On the device standpoint, if you can get your platform through, maybe it's class 2, maybe it's a 510K. You upgrade it, maybe that's a special 510K, a little bit lighter weight. So this concept of where is common sense, hopefully with software, there might even be some finer points that can go through easier, but I would definitely defer to the panelists on that. We asked our new Chief Business Officer, Chris. Chris, can you go find out, tell me how many people die of stomach cancer every day around the world? And he came back to me and he said, okay, it's every 37 seconds. And so, we've got some patents filed, and I sure hope that this company and this team can take this all the way. But I have to ask myself, am I more important than one person dying every 37 seconds for lack of this kind of technology? And that's just in one tiny sector of human health. And so what I've told my entire team and our investors and our doctors and stakeholders is that, to use an old metaphor, we've burned the ships. We're here on the shore, we've chosen this as our mission. We are all in on this, but if someone else actually can do this better, our hats will be off to them, because there are millions of people who are caught in between a standard of care that can often lag behind other types of technology, and then people that want to make it happen. And I think if we focus on the patients and we ask doctors how to help them do their job, good things will happen. Absolutely. At some point you get tired of making other people's dreams come true. And for me, that happened at age 37. I just kind of ground to a halt in the med device scene. And I realized, if I don't try this robot pill thing now, I'm never going to be able to be comfortable in my own skin. And so I went into the Founder Institute and basically said, I want to make robots that go in the body. And they said, what's the market for that? And I said, what's a market? And they said, where in the body? And I was like, I don't know, maybe you swallow it or something. And they were kind of blown away. And I said, no, this is just, I want to do this. And so initially we said, we're going to make robots that are going to drive through the GI tract in 30 minutes or less. That was our original tagline. They're like, how are you going to do that? We said, I don't know, we'll figure it out. And so we started prototyping, trying to do inchworming, corkscrewing, flagellating, feet that were walking, swimmers. And after tying countless pig intestines from the local market in knots, we realized this is harder than we thought it would be. And our first real pivot came in. And what happened was a doctor said, if you drink a lot of water, your stomach would inflate and you might be able to be effective swimming around in the stomach. And we said, okay, well, maybe we could do that. And we started to realize, you know, a quadcopter drone flies through the air in an organic way. Maybe a quadcopter robot could swim in the stomach. And so we pivoted, we got a little bit more realistic. We're down to 3 motors now. But the neat thing was, you go in there with your dream, you learn what you can, and then when necessary, you make a couple of reasonable compromises. And it turns out the stomach is a wonderful place to start. So I would take your passion and your dream and go all in on it, but you know, learn as you go and be a little pragmatic.
I don't think we can.
Sideways on it, which is just that I can't wait. You know, we've all lost a loved one or seen someone that, you know, get sick. And I'd just like to say that we are putting extreme bias into this technology because we intend to terminate cancer with extreme prejudice.
Touche.
You know, I love diagnosis, but TX means to treat. And so as soon as we're doing decent diagnosis, we're putting the robot arms and we're gonna go kill that cancer where it lives. And so I would never want to pigeonhole this technology into diagnostics. We definitely want to go further. Just say that I wish we lived in a world where doctors didn't get tired, right? Or where drivers didn't get tired. And if we look at a pill that can drive itself, but might make an error, or a self-driving car that makes a new kind of error. Let's make sure that we're looking backwards as well and understanding, you know, what we've grown accustomed to. I hope that there's a path forward here, because there are new types of risks, and those come with a flavor that people aren't used to yet.
I hope the same.